On this example, we're going to go ahead and expand a logarithmic function completely. So to get going on this, jumping out the right direction, I noticed that on the inside of our logarithm, we have a fraction. That fraction can be divided into two different logs. Both of these logs are going to be log base 4. The first one's going to be our numerator, 64x to the third power, and then we subtract, and the second one gets to be our denominator. Back to properties of logarithmic functions, right? All right, next thing I notice on this one is we do have a multiplication going on inside of that first logarithm. We have 64 multiplied by x to the third power. So what I'm going to do next is go ahead and split that apart. When we have multiplication, we can make this two separate logs, but it's going to be addition on the inside, in between these two logs. For this last log, what I'm going to go ahead and do is I'm going to say that's x minus 1, but instead of having a square root over the whole thing, instead we can use properties of exponents and write this as a 1/2 power instead of a square root over top of the x minus 1. All right, we're almost there, but we have a little bit more simplifying we can do. All right, one thing I definitely notice is we do have everything on the inside of the x to the third power here. That 3, the exponent, is attached to everything on the inside of that log. We've also rewritten this, so the 1/2, that exponent, is attached to everything on the inside of that log. So what we're allowed to do is we're allowed to move these down in front using that property of a logarithm and make that a product. So make those multiples in front of those logs. So if you'll bear with me, I'm going to bring that 3 down in front. It'll still remain log base 4 of x, because all we did was move that exponent down. This is still going to be a minus out in front. The 1/2 comes down. Log base 4 of x minus 1 is still on the inside there. But let's think about this very first logarithm. We have log base 4 of 64. We can do a little bit more reducing down and simplifying on this one if we can rewrite this, because we have log base 4 as our base here. If you can rewrite the inside here as 4 raised to a power, so rewriting 64, I believe we can say that's 4 raised to the third power, right? 4 times 4 is 16. 16 times 4 makes 64. Because we can line it up just like this, where we have the same exact base, log base 4, and then an exponential, 4 raised to a power, whenever this is the case, we get this really nice canceling out, and we're going to be able to say that this first one reduces down just to be 3. Everything else can come along. 3 times log base 4 of x minus 1/2, log base 4 of x minus 1. Now, if you use photomath, you probably didn't get to this exact same looking answer when we get done, and it's a dead giveaway that you use photomath or another application from your phone, from the internet, that just gave you the answer and you didn't know what was going on. All right, it wouldn't make any sense in these cases to change from log base 4 across the board to log base 2 anywhere along the way. So I hope this helps out as you're learning the steps, the process for using the properties of logarithmic functions and expanding. All right, good luck.